Integrals of select functions. Let's start off with the polynomial power function. So the integral of ax to the power of n dx. What is that equal to? Okay, well, let's remember what the derivative is. So the derivative, d by dx, of some function, let's say x squared, is equal to 2x. Okay, so to the power of 1. So the 2 comes down and a minus 1. So if I took the integral of this thing, I would go on and have to get that back. So I have to add 1 to the top here. So it's going to be x to the n plus 1. And then I have to divide by that value, right? So it's going to be a to the n plus 1. There it is. Okay, so if I take the derivative of this function here, I will get that back. Because I'm going to have the n plus 1 come down, cancel with that guy, and then minus 1. So it'll be ax to the power of n. And that's what I have right here. Now, it's not completely complete because there is something else I can add to this to make it more general. And that's going to be plus c. Okay, because any constant, 4, 17, 4,406. If I take the derivative of that constant, I'll get 0. So I can still take the derivative of this thing, and I'll still get that back. So that's the most general case that I can do. Never forget that plus c. Also, this is not the complete picture. There is one exception to this one, and that is n cannot equal negative 1. Okay, for that one special case, you can look back at your derivatives, but you could never take the derivative and it lead to constant. No, that's not true. But it's hard to take the integral of a constant to get back that first one. Or to when you have n to negative 1. Or x 1 over x, that's what it is. It's not the constant problem, it's the 1 over x. There's a special case there. It's going to be ln of x. And you can look at that in your derivative section. So the derivative of ln of x is 1 over x. Okay, there's no derivative of this where you make the 1 over x just because of the subtraction of 1. So this is for n equals negative 1. Okay, so those are the two ways to do it for the integral of a polynomial. There's a special case there for if n equals negative 1. Okay, let's do a trig function. So the integral of sine of x dx is equal to, okay, well I know it's going to be cosine plus the c, don't forget that. Now the derivative of cosine is negative sine, so I have to put a negative here. Okay, that'll make it better. Okay, let's do the integral of cosine x dx. Well, I know it's going to be sine of x plus c. Now the derivative of sine is cosine, so I don't need a negative there. So that's perfect. Okay, just for completeness, we'll put the integral of tan x dx, and that's going to be equal to ln of secant x. That's actually absolute value plus c. Lastly, exponentials and logs. So the integral of an exponential, well, I know the derivative of exponential is always the exponential itself, so I know it has to be the exponential, but it always has multiplied by ln of the base, so I'm going to have to divide by ln of the base. Okay, so when I take the derivative of this thing, I'm going to take, it'll be a to the x times ln of a, which will cancel with this guy, plus c. And lastly, the integral of ln of x dx is equal to x ln of x plus, minus x. Integrals of select functions.